Ready? Let's get to it. Number 10. Jupiter's mass is Earth's first line of defense. Jupiter's sheer size is absolutely insane, making it a gravitational fortress unlike anything else in our solar system. Calling it big doesn't even come close. It's basically the main character of the planets. If you hollow Jupiter out like a shell, you could fit over 1,300 Earths inside it. Its diameter stretches nearly 87,000 miles across, roughly 11 times wider than Earth. But the real flex isn't just the size, it's the mass. Jupiter contains 318 times more mass than our planet. To put that in perspective, if you gathered every other planet, Mercury, Venus, Earth, Mars, Saturn, Uranus, and Neptune, and combined them into one object, Jupiter would still outweigh them by more than 2.5 times. It's not just in the neighborhood, it is the neighborhood, dominating in a way nothing else comes close to matching. What makes this suspicious is what that gravity actually does. Jupiter's immense mass creates a gravity well so deep and so wide that it warps the trajectories of objects passing through the outer solar system. Comets speeding in from the distant reaches of space suddenly find their paths bent. Asteroids drifting too close get pulled in or flung away into interstellar space. Jupiter acts like a cosmic bouncer stationed at the edge of the inner solar system, deciding what gets through and what does not. Its surface gravity is about 2.5 times stronger than Earth's. An object that weighs 100 pounds on our planet would feel like 250 pounds on Jupiter, assuming you could somehow stand on its gaseous surface. Without something this massive sitting where it does, the inner planets would face a far more dangerous neighborhood. Jupiter is not just a planet, it is a gravitational gatekeeper, and Earth happens to live behind the velvet rope. Number 9, Jupiter takes the hits so we don't have to. Jupiter is constantly getting hit, so Earth does not have to. If you think our planet gets pelted by space debris, Jupiter is out here playing a high stakes game of dodgeball where it never ducks. Scientists estimate that Jupiter experienced between 2,000 and 8,000 times more comet impacts than Earth does. Objects roughly 30 feet across slam into the gas giant somewhere between 12 and 45 times every single year. On Earth, a collision of that size happens maybe once every 6 to 15 years. Jupiter is taking hits constantly, and most of the time, we never even notice because the impacts simply vanish into its massive atmosphere. That is some serious dedication to the job. Here's the thing that makes this feel almost intentional. Jupiter sits in a strategic position. It orbits at about 5.2 astronomical units from the Sun, roughly 5 times the Earth to Sun distance, placing it right at the edge of where icy comets begin their long journeys inward from the outer solar system. When a comet drifts toward the inner planets, Jupiter often intercepts it first. Sometimes the comet gets absorbed directly, swallowed by the gas giant's immense atmosphere. Sometimes it gets redirected into a harmless trajectory that carries it away from Earth entirely. And sometimes, if the comet strays too close, Jupiter's tidal forces rip it apart into fragments before the pieces can threaten anyone. Either way, Jupiter acts as a shield that reduces the number of deadly objects that ever reach our corner of space. The gas giant is not passively existing out there. It is actively absorbing cosmic shrapnel on our behalf, and it has been doing so for over 4 billion years. At this point, it deserves a thank you card. Number 8. Shoemaker-Levy 9 was a warning shot we got to watch. Shoemaker-Levy 9 showed us exactly what Jupiter does for Earth. In July of 1994, humanity witnessed something unprecedented in the history of astronomy. A comet named Shoemaker-Levy 9, discovered just a year earlier by astronomers Carolyn and Eugene Shoemaker and David Levy, even came back for a catastrophic collision with Jupiter. The comet had been captured by Jupiter's gravity during an earlier orbit and torn apart by tidal forces in 1992. What remained was a string of 21 fragments stretching over 1 million kilometers through space, like pearls on a cosmic necklace of doom, all headed directly for the gas giant. Over 6 days, from July 16th to July 22nd, those fragments slammed into Jupiter's southern hemisphere one after another. Each impact released catastrophic energy. The fragments were traveling at roughly 130,000 miles per hour, about 60 kilometers per second, when they hit. The largest fragment, designated Fragment G struck with a force equivalent to roughly 48 billion tons of TNT. That is several times the combined explosive power of every nuclear weapon ever built on Earth, detonating simultaneously. Temperatures at the impact sites briefly reached over 40,000 degrees Kelvin. The plumes of superheated gas shot nearly 2,000 miles above Jupiter's cloud tops before collapsing back down. But here is what made the event truly haunting. Some of the impact scars left behind were larger than Earth itself. One dark bruise stretched over 7,000 miles across and remained visible for months. If even one of those fragments had struck Earth instead, it would have been game over for most complex life on the planet. Shoemaker Levy 9 was not just a scientific event, it was a demonstration. Jupiter basically looked at the inner solar system and said, "Not on my watch." It catches dangerous objects, but tears them apart and absorbs them. Earth was watching from a safe distance, and that distance exists because Jupiter was there first. Number 7. Jupiter didn't just protect Earth, it helped build it. Jupiter did not just protect Earth, it may have helped create it. Long before Earth existed as the rocky blue world we know today, the early solar system was a violent and chaotic place. Debris flew everywhere, protoplanets collided and merged. The sun was still stabilizing from its formation, and Jupiter, which formed within the first few million years after the sun ignited, played a central role in shaping what came next. Jupiter grew so quickly that it accumulated most of the leftover gas and dust that did not fall into the sun, becoming the dominant gravitational force in the young solar system. But it was basically the first one to claim a seat at the table, and it took the biggest chair. According to a theory called the Grand Tack, Jupiter did not simply form in its current position and stay there. It actually migrated inward toward the sun, traveling as close as 1.5 astronomical units, roughly where Mars orbits today. This inward migration would have been catastrophic for anything in its path. But then Saturn finished forming and caught up with Jupiter, locking the two giants into a gravitational resonance that reversed Jupiter's direction. The gas giant began migrating outward again, eventually settling near its current orbit around 5 astronomical units from the Sun. What makes this suspicious is what that migration accomplished. As Jupiter moved inward, it scattered and cleared material from the region between Mars and the asteroid belt. This is why Mars ended up so small, only about 1/10 of Earth's mass. Jupiter essentially starved it of building material. Sorry, Mars. When Jupiter then migrated outward, it pushed icy asteroids and water rich debris from the outer solar system inward. Some of that material eventually collided with the early Earth, delivering water and organic compounds essential for life. Jupiter did not just protect our planet, it may have helped assemble the very ingredients that made Earth habitable. It sculpted the solar system like a cosmic architect, and we are living in the house it designed. Number 6. Jupiter babysits over 1 million asteroids. Jupiter herds over 1 million asteroids to keep them out of our way. Between the orbits of Mars and Jupiter lies the asteroid belt, a region containing hundreds of thousands of rocky objects ranging from small boulders to dwarf planets like Ceres. For a long time, scientists wondered why this belt never coalesced into a planet. After all, there was clearly plenty of material there at some point. The answer is Jupiter. The gas giant's immense gravitational influence continuously stirs and disrupts the asteroid belt, preventing the material from ever clumping together into something larger. Jupiter is essentially a full-time shepherd, and the asteroids are its very unruly flock. Every time asteroids in the belt begin drifting into orbits that might allow them to merge, Jupiter's gravity nudges them back apart. Near regions called Kirkwood gaps exist within the belt, where almost no asteroids can survive because Jupiter's gravitational resonances make those orbits unstable. Objects that wander into these gaps get ejected or redirected. Jupiter essentially prevents the asteroid belt from ever becoming a threat by keeping it fragmented and chaotic. But here is where it gets even more interesting. Jupiter does not just keep the asteroid belt chaotic, it also traps enormous numbers of asteroids in specific, predictable locations called Lagrange points. These are gravitational sweet spots 60 degrees ahead of and behind Jupiter in its orbit, where the combined gravity of Jupiter and the Sun creates stable zones. Objects that drift into these regions can remain there for billions of years. Over 15,000 of these so called Trojan asteroids have been discovered so far, and scientists estimate the total population may exceed 1 million objects larger than half a mile across. Jupiter essentially corralled these asteroids into a timeout corner where they cannot bother anyone. It is not just deflecting random debris, it is actively organizing and containing an entire population of potentially dangerous objects. The asteroid belt exists in its current, relatively safe configuration because Jupiter keeps it that way. Number 5. Jupiter ejects the most dangerous comets permanently. Jupiter flings long period comets out of the solar system entirely. The most dangerous objects in our cosmic neighborhood are not necessarily the asteroids nearby. They are the long period comets, icy bodies that originate in the distant Oort cloud, a theoretical shell of frozen debris extending nearly halfway to the nearest star, roughly 1 to 2 light years from the Sun. These comets can take millions of years to complete a single orbit, and when they do swing through the inner solar system, they arrive fast, cold, and often without any warning. They do not call ahead. Long period comets are terrifying precisely because they are so unpredictable. Unlike asteroids in stable orbits that we can track for decades, these ancient wanderers appear suddenly, dive toward the sun at incredible speeds, and then vanish back into the void. A long period comet large enough to cause an extinction event could be discovered only months before impact, leaving little time for any kind of planetary defense. They represent one of the most serious cosmic threats to Earth. Jupiter plays a critical role in dealing with these threats. When a long period comet drifts too close to the gas giant during its journey through the outer solar system, Jupiter's gravity can dramatically alter its trajectory. In many cases, the comet gets accelerated to escape velocity and flung entirely out of the solar system, never to return. Scientists estimate that without Jupiter, long period comets would strike Earth roughly 1,000 times more frequently. That is not a small difference. That is the difference between mass extinctions happening every few tens of millions of years versus happening constantly throughout Earth's history. Jupiter acts as a cosmic slingshot. When catching these ancient wanderers and hurling them into interstellar space before they ever get a chance to threaten Earth. Problem solved. Permanently. Number 4. We're watching Jupiter take hits in real time. Amateur astronomers keep catching Jupiter taking hits for us in real time. Since 1994, something remarkable has happened. Ordinary people with backyard telescopes have begun documenting impacts on Jupiter as they occur. The technology has improved dramatically. High quality cameras and digital imaging now allow dedicated observers to monitor the gas giant continuously, recording events that would have gone unnoticed just a few decades ago. And what they have found confirms that Jupiter is under constant bombardment. It is like watching a bodyguard at work, and the bodyguard never takes a day off. In July of 2009, exactly 15 years after Shoemaker Levy 9, an Australian amateur astronomer named Anthony Wesley noticed a fresh dark scar near Jupiter's south pole while observing from his backyard. He alerted professional astronomers, and NASA's Hubble Space Telescope confirmed the discovery. Analysis revealed the scar was caused by an asteroid roughly 200 to 500 meters wide, an object that would have caused catastrophic damage if it had hit Earth instead. The impact created a bruise the size of the Pacific Ocean that remained visible for months. But here is the kicker. It kept happening. In June of 2010, Wesley spotted another impact flash on Jupiter. 2 months later, in August, Japanese astronomers recorded yet another collision. In September of 2012, an observer in Wisconsin named Dan Peterson watched a fireball bloom on Jupiter's surface and had his observation confirmed by another astronomer in Texas named George Hall, who happened to be recording at the same moment. In March of 2016, 2 independent observers in Austria and Ireland captured footage of yet another strike. In 2021 and 2023, more impacts were documented. These are not rare events. Jupiter is getting hit constantly, and now we have the technology to watch it happen. Every flash of light we record on Jupiter's surface is essentially a thank you note to the universe for not sending that rock our way. Scientists estimate the impacts of this size might occur on Jupiter 10 to 50 times per year. We are watching our cosmic shield in action. You're absorbing hit after hit so we do not have to. Number three, Jupiter may have destroyed a generation of planets to save us. Jupiter may have destroyed an entire generation of planets to save us. When astronomers began discovering exoplanets around other stars, they found something puzzling. Most solar systems look nothing like ours. The majority of planetary systems discovered so far contain super Earths, rocky planets between 1 and 10 times Earth's mass, orbiting extremely close to their host stars. In fact, super Earths appear to be the most common type of planet in our galaxy, yet our solar system has no super Earths at all. Mercury, Venus, Earth, and Mars are all relatively small, and the inner solar system is strangely empty compared to what we see elsewhere in the galaxy. It is like everyone else got a packed apartment, and we got a spacious house with a yard. Scientists wondered for years why our solar system was different. Other stars seem to have planets packed tightly around them in compact configurations. We have vast empty spaces and relatively tiny terrestrial worlds. What happened here that did not happen everywhere else? What makes this suspicious is the leading explanation. According to some models, Jupiter may have destroyed a primordial generation of super Earths early in our solar system's history. As Jupiter migrated inward during the Grand Tack, it would have shepherded planetesimals ahead of it, grinding them into dust through high speed collisions. The debris from these collisions, dragged by gas in the early solar nebula, would have spiraled into the sun, in taking any early planets with it. Jupiter essentially acted like a cosmic wrecking ball, clearing the inner solar system of whatever was already forming there. When Jupiter then retreated outward, it left behind a depleted inner disk from which only smaller terrestrial planets like Earth could eventually form. Our solar system's unusual structure, with small, rocky inner planets and giant outer planets, may exist specifically because Jupiter cleared the slate and allowed a second generation of worlds to emerge. We might owe our existence to planetary destruction on a massive scale. Jupiter did not just protect Earth from impacts, it may have prevented a completely different kind of planet from ever forming in our neighborhood. Harsh, but effective. Number two, Jupiter delivered the water that made life possible. And Jupiter helped deliver the water that made life possible on Earth. One of the great mysteries of our planet is where all the water came from. Earth formed close to the young sun, in a region hot enough that any water present during initial formation would have vaporized and escaped into space. The early Earth was a molten, hellish world with no oceans, no lakes, no rivers. Yet today, over 70% of our planet's surface is covered by liquid water, oceans averaging more than 2 miles deep. That water had to come from somewhere else. And Jupiter, once again, was involved in the delivery. Here is how it worked. During the late heavy bombardment, a period roughly 4 billion years ago, when the inner solar system was pummeled by asteroids and comets, Jupiter's gravitational influence scattered water-rich objects inward from the outer solar system. The migration of the giant planets stirred up the debris remaining from solar system formation. Icy asteroids and comets carrying frozen water collided with Earth, gradually filling its oceans over hundreds of millions of years. It was the longest, most chaotic delivery service in history. The molecular signature of Earth's water provides evidence for this. Scientists measure the ratio of deuterium to regular hydrogen in water samples. Deuterium is a heavier isotope of hydrogen that tends to be more common in objects formed in colder regions of the solar system. Recent studies have found that Earth's water matches the composition found in certain carbonaceous asteroids and Jupiter family comets, supporting the delivery mechanism theory. A NASA-led study in early 2025 even found that measuring water close to comet surfaces yields results consistent with Earth's oceans. Jupiter did not just protect Earth from deadly impacts. It also directed the beneficial ones, sending water to a planet that desperately needed it. The oceans you see today, the water that makes up most of your body, may exist because Jupiter aimed the right objects at Earth at the right time. So the next time you drink a glass of water, you can thank a 4 billion year old gravitational assist. Number one, Jupiter's protection isn't perfect, and that's the point. Jupiter's protection is not perfect, and that might be the most important part. For all of Jupiter's protective qualities, scientists now understand something crucial. Jupiter does not always shield us, and sometimes it makes things worse. Computer simulations have shown that while Jupiter deflects many comets and asteroids, it also gravitationally perturbs the orbits of other objects, occasionally redirecting them toward Earth rather than away from it. Jupiter reduces long period comet impacts but may actually increase collisions from asteroids and short period comets. The relationship is complicated. Even cosmic bodyguards have their flaws. Research published in the late 2000s by scientists like John T. Horner and Barry Jones found that Jupiter's influence works both ways. For objects originating in the Oort cloud, Jupiter provides substantial protection by flinging them out of the solar system. But for objects already in the inner solar system or the asteroid belt, and Jupiter's gravitational stirring can destabilize their orbits and send them crashing toward Earth. Jupiter protects us from some threats while creating others. The net effect depends on exactly where the dangerous objects originate. What makes this truly suspicious is that the balance seems almost perfectly calibrated. If Jupiter were much less massive, it would provide little protection at all. Comets would stream through the inner solar system unchecked. Extinction level impacts would happen far more frequently. But if Jupiter were significantly more massive, its gravitational disruptions might overwhelm the benefits, sending more deadly objects our way than it deflects. Jupiter exists in a narrow range where it provides substantial protection without causing excessive harm. And it reduces the overall threat level just enough to make complex life possible over billions of years. Too little protection and extinction events happen too frequently for intelligence to evolve. Too much interference, and the solar system becomes unstable, with planets migrating chaotically or getting ejected entirely. Jupiter sits precisely in the zone where its influence helps more than it hurts. Its mass, its position, and its orbital characteristics all fall within the parameters that make long term habitability possible, whether that is pure cosmic luck, the result of some unknown physical process that selects for stable planetary systems, or something we do not yet understand. The result is the same. We are here because Jupiter is exactly what it is, in exactly the position where it orbits, exerting exactly the right amount of gravitational force. And that feels less like an accident and more like a system designed to give life a fighting chance. Jupiter is not just a planet, it is one of the most important reasons Earth became the world it is today. And honestly, it does not get nearly enough credit. Thank you for watching and sticking till the end. We have got plenty more videos coming in the future. Hit that subscribe button so you do not miss them.